So the pretest today or tomorrow, it's at PSA 21. You need to be in the door between 10:30 and 6:30. You can work until 8. You need a valid Sun card. It has to be a Sun card. And what else? Don't bring a calculator. Don't study, but do your best. Okay. Everyone's required to take it. There's no exceptions. Everyone has to take it. And based on your performance, I'll give you some bonus on exam 1. Okay. And then web work. You have the next set is due Friday before class, and then I'm going to post Wednesday set. Okay. This Friday's web work, some of the questions you get 3 attempts, and some you get 5. And that's going to be typical from here on out. So watch carefully. It'll monitor it for you. But make sure that you see how many attempts you have left. So shorter, more quick questions, 3 attempts. Longer, more involved questions, 5 attempts. So you'll have one due Friday. You'll have one due Wednesday. And then written homework has been posted. It's due next week in recitation. So are you guys the Friday, some are Wednesday, some are Friday, is that right? Yeah, so you'll turn that in either Wednesday or Friday in recitation. Okay? So you'll have, some of you will have recitation today, and then some of you will have recitation Friday, and then you'll actually be going over homework questions that you have in recitation this week. Next week, you'll be turning in the first written homework. Okay, any questions about all that stuff? Okay, what do we think about this classroom? Is it better?
Yes.
Lily, you got a little more leg room? Okay.
For web work and written homework, where do you post that stuff online? Is that on Blackboard?
Well, the web work, just when I put the set up, you just go to web work. It's up. You'll just see, you'll just see in the list of assignments, and they'll tell you when they're due. So you just show up on web work. The written homework is on Blackboard. Yeah, the written homework is on Blackboard. There's a link called assignments.
Are you posting those every? Is there going to be a new set every single class that we have? So should I put a reminder to check every single?
Which web work? For now, web work is every class. It might change, but for now, pretty much there will be something due before every class. Written is once a week. Written is once a week. 4-hour course. So yeah, a lot of work outside of class. It's a 4-hour course. So expect a lot of work. These are good questions. Any other questions? Yes? Say it again? I don't understand what you're saying. Something about Megan's email?
She sent us like a good like help or something.
Okay.
I don't know if it was on her chat 171.
I don't understand the question.
I don't know who it is.
Megan is your TA, is your recitation TA. Yeah, so she's no, Megan is the other recitation TA. Roy is your TA. But Megan is the other recitation TA, so she sent it out to all of my 171 students?
Yeah.
Okay, was it informative? Or was it confusing? Yeah, so if you get it, yeah, so she just meant to send it to my other 171 class. So your TA is Roy. Okay, sorry, I understand that. So you don't know who Megan is, and you shouldn't. Okay. So if you get an email from Megan, it's pertaining to my other 171 class. Other questions? Yes, sir. It'll probably take you less than an hour. Okay, so stay out of this section right here. So find a seat over here. It'll probably take you less than an hour altogether. Other questions? Okay, should we get going here? We got roll, we got announcements. Okay, so I got this right here. It says, let Z equal the amount of rainfall in Tempe since August 1 in centimeters. We're talking about defining variables, and I'm wondering what you think about this definition of this variable. Where's Shruti? Shruti, what do you think about this variable I've defined? Do you like it, or do you think it's not a valid definition? Valid. Okay. Because? It's well defined, specific, okay? Is there any question about what it means? Okay, it's a quantity, right? So it's a quantity and it's specific, and our last, it has units. Good definition, right? Good definition of a variable. It's a quantity that's specific and it has units. Okay? So now, I've got this image here, and this is totally related to variable z. Don't bring any new quantities into it. This is just related to variable z. Okay? So I'm going to show you that I can take the red bar, and this is what I can do with the red bar. Okay? That blue bar, I can change its length, and I can also move it. So only variable z. So don't try to bring time in it. Don't try to bring any other quantity into it. Only the variable z. What do you suppose, or what's the most kind of logical explanation for logical meaning for the red bar relative to z and the blue bar relative to z? So let's just set it right here. Okay, just come over as far as you can. Stay out of that section. All right, so what is the meaning of the red bar? What is the meaning of the blue bar? Talk to the person next to you for about a minute. Only variable z, only quantity z. Okay, let's see how you did. Where's Jonathan Leeson? Okay, Jonathan. So it was one thing you figured out about the red and blue bars.
The red bar is the total amount of variable centimeters.
Okay, so what does that have to do with the variable z? So easy it's hard, right? What is it? It's z, right? So the red bar is representing the quantity z. So here we are at the beginning of the month. Is that what you guys came up with? Yes, here we are at the beginning of the month, and as time goes by, our centimeters of rainfall, so maybe as time, maybe it's only be like this, right? Less than a centimeter, right? We live in the desert. But hopefully, as time goes by through August, that quantity will increase. Stay out of this section here. Come over here. Okay? Right, so what am I showing right now with the red bar? What is the red bar showing right now? Yeah?
Specific days after August 1st.
No, it's nothing to do with days. It's just the quantity z. It's nothing to do with time. What is it showing right now? Right, and what is the current value of that? 8. Right now it's showing that there's been 8 centimeters of rain since August 1st. Maybe in a week, it will change, right? That's what variables do. They take on different values. So in a week later, now the value of z is 8.75 or 8.8 or something like that, right? Okay, somebody new. How about the blue bar? Let's try, where's Adam Nichols? Adam. Yeah. How about the blue bar? What did you think the blue bar meant? Relative to z, about z. This is what we talked about at the end of class last time. Any idea? How about Brian Sloan?
That means something like amount of rain in 1 day.
The amount of rain in 1 day. What do we think? Tell me right here. The change. What change? Be specific. Change between months. A range. The average. Man, amount of rain last year.
The change of Z after 3 centimeters.
And what is that change? What is it showing? Try again. You almost got it. Okay? So, how do we, if it's the change in the amount of rainfall, what's our symbols for that? Delta Z. And what's the value of delta Z currently? 3.5. Specifically, it's the change in the amount of rainfall starting at August 1st? Starting at 3 centimeters. Starting at 3 centimeters of rain up until 6.5 centimeters of rain. Is that the only delta Z of 3.5 that we could have? Yeah, so that delta Z can can rove. That's not the right one. So here, this is also delta Z of 3.5, but how is it different? Where is Taylor? Taylor Sloan. Where's Taylor? No learn faces, can't hide. See him. No Taylor? Kiana. Kiko. So what does the blue bar represent right now? What's that? The change in Z starting after 0.5. Is it Adam? You Adam? You want to say something now? Go for it. Oh, you were stretching. Okay, sorry. She said the change in Z starting at now 0.5 centimeters of rain. And how much is the change in Z now? Still 3.5. So it's a change from when there was 0.5 centimeters of rain up till 4 centimeters of rain. So this is this idea of the change in a quantity. It can start at any value of the quantity. And then we can change the amount of change, right? So then we can look at a small amount of change, say. Maybe. Okay, so just real quick, one more example. So analyze the whole picture. So talk to the person next to you. The whole thing. So explain what the whole thing means. Go. Okay, let's see how you did. What are we showing now? So where's Farah? Farah, are you here? Can you tell me what this is showing now? The whole thing. The red one is the amount of rain, and what is it? 1.7, right? So currently the amount of rain that's fallen in Tempe in August, 1.7. Keep going, doing good. It's what? Delta Z, which means what? Difference? What is that blue bar? What does delta Z mean? Where's Nathan Zarta?
It's the change, the increase amount of rain.
The increase in the amount of rain, the change, and how much is it?
0.5.
0.5. So it's like we're at 1.7 centimeters of rain in August, and then there was another rainfall, and it made it change by half a centimeter. Does it make sense? So really important to get this concept of a change in a variable, delta Z. Yeah.
So all amount of rain is 1.7 plus 0.5?
Yeah, so exactly. So it's like at a certain date we had 1.7, then maybe overnight we had 0.5 more. So now the new amount would be, what, 2.2 or something. Yeah. So the new total amount of rain would be the sum of the two, 2.2. Okay. Cool. Yes, sir.
How would it be represented in the delta Z
Yeah.
if you were to lose rain?
Yeah, well, you would never. That would, in this case, yeah, you're right. So he's bringing up a good point. A change in a variable can be positive or negative. It could be positive or negative. We can have an increase, and that's a positive delta Z. Or we could have a decrease. That's a negative delta Z. In this example, you would never have a decrease because their rain always increases or stays constant. It would never. The amount of rain would never decrease. It evaporates, but that's not what they're measuring. They're measuring how much rain fell. So, but yes, a change in a variable can take on a negative value, and that means that quantity is decreasing that much. Yeah.
The red one represents the total Z. How is that adjusted Z after? I don't understand.
Yeah, go ahead.
What I think is catching a lot of people is it feels not to incorporate another variable, and you're kind of almost happy to be fine just because you have an additional amount of what he doesn't understand is why the total way out of difference higher than the total.
Yeah.
So I get it. It's just you have to factor in another variable. It's like a half variable.
No, you don't really. So, okay, how about this? So we've had 1.7 centimeters of rain until now, and we're forecasting that tonight there's going to be another 0.5 centimeters. So that would be the change tonight. How about that? Is that better? Yeah. Yeah. Or you can add them together and say the total is the new red bar length, right? If you add them together, then that becomes the new red bar length. Okay? Cool. Other questions? Those are good questions. Yes, ma'am? No, it's a change. So we can be at a certain amount and then have a change, but then once we have that change, then the variable catches up to it. Yeah. Okay? All right, so we're gonna serve up a delicious chicken dish. So we need to go to the grocery store and we need to buy some chicken. And chicken at this grocery store costs $3 a pound. $3 a pound, okay? So how about my variables there? I'm saying X is total weight of chicken in pounds. Y is the cost of the chicken in dollars. How did I do defining those variables? Thumbs up? Are they quantities, first of all? Quantities. Are they specific? Is there any question about what quantity we're talking about? Nope. Are there units? Right. I've got good variables there. Okay? So, the butcher throws a pound of chicken on the scale. What's the cost in dollars? 3. And when I do that, that plots a point. So before we just had the rainfall, which is the horizontal scale. So here's the same thing. The horizontal scale is my X quantity, the total weight of the chicken in pounds. And then now on the vertical scale, like imagine that rainfall tipped up this way, that quantity is the cost in dollars. So I get this point. What does the point represent? Exactly what does the point represent? Volunteer, yes sir. Okay, so each pound or 1 pound? 1 pound, exactly right. So a point on a graph really represents how many pieces of information? 2 pieces of information. It represents the value of one quantity, in this case, the weight, 1 pound, and also the corresponding $3 for the other. So that's what that point represents. It represents like a packet of information. The value of the first quantity and the corresponding or associated value of the second quantity together. So a point gives us 2 pieces of information. Okay, I want to buy 7 pounds. How much? 21. That's going to move my first point down here now. So, oh, shoot. Okay, it's going to move my first point down here. So this is my 1-3, and this is my 7-21. What does the point up here to the upper right, what does it represent? Jocelyn. Where's Jocelyn? Jocelyn, what does that point up in the upper right represent? The point represents a change? Tell me exactly. What amount of chicken? Okay, it represents that if there's 7 pounds, what? It's going to cost $21. It represents both pieces of information together. That's what that point represents. Okay? 3 pounds, how much does it cost? 12 pounds. Every time I put in a weight and an associated cost, I get a point. Is this the only possibilities for buying chicken at the store? How many possibilities are there? Right. So let's put a whole bunch up there. Okay? Ready? What happened? So what do we have now? We have lots of points, and each point represents a weight of chicken and the associated cost. Each one of those points represents a weight of chicken and associated cost. If I zoom out, what do you see? You see a line, right? You see a line. But what does that line consist of? Not what does the line represent, but what does it consist of? What is it made of? Points, okay? That's what a graph is. It's a set of points. I can open this up like this. But really, when you see graphs you see all kinds of graphs, and it's kind of like it looks kind of like a wire or a stick, right? But it's not a wire or a stick. It consists of points. It's points, and each point is this packet of information, 2 quantities taken together. Okay, so I'm back to my original points here. So what you're used to seeing then so I showed you all those points lined up, right? And when we zoomed out, we saw what appeared to be a line. Okay? So how many points are there on this line? There's 5 points on this line, right? Right? 5 points. What do you think? Adrian. Where's Adrian? How many points are on this line? 5 points. Agree with that? So, see? Oh, if I cut those, it'll cut the line too. Okay? So, how many points are on that line? Too many to count. Too many to count. All right? So, that's the point. When you see this thing that you draw with a pencil, or the graph is drawing this black, continuous black thing, you have to imagine that is all points. It's not a wire that you bend, or sometimes it's straight and you can move it around. It's a set of points. It's really crucial that you see it as a set of points. Okay? So now we want to start talking about changes. So what is all about changes here? So just imagine right now, that graph is the way I had it before, when I had all those points over here, all that data, and it was just a continuous string of blue points, right? That's what still you should be imagining when you see this, when you look at this. Okay. So let's start talking about changes now. Changes in the quantities. Okay? So if x changes from 1 to 7, what does y change from? Where's Zach Amio? Zachary Amio? Right here? Tell me. As x changes from 1 to 7, what does y change from? What is it? He wants 3 to 21. Agree? Cool. What is the change in x? Did the weight of the chicken go up 6? 6 pounds? Okay. And how much did the cost change? 18. All right. So this is this idea of the change in a quantity. So if x starts at 1 and ends at 7, the number of pounds just went up 6. And we call that delta x. We call that delta x. And then simultaneously, when that amount of chicken went up from 1 to 7, our cost went up 18, right? So how can we show that on the graph? I want to show that on the graph. So where would I start? Where would I start? The point one, I would start right here, right? And I first want to talk about the change in x. How could I show the change in x on this graph? Where would I go from there? Up, right, left, or down? How far? That's the best line I drew all day. Okay? And so that right there represents, just like the red and just like the blue bar, right? On the rainfall, the blue bar, remember that? Same thing. This represents delta what? Of equal to 6 from 1 to 7 pounds. And while we increased the pounds 6, what happened to the cost? Went up 18. And how do I show that? Right? So this is like going from what? What did we say? From what to what? From 3 to 21. So that's that change right there on the cost scale. We're just going to show it over here. Okay? So that's delta y equals? Oh, 18? All right. And we'll throw the units on there. $18, 6 pounds. Okay, I'll stop here. Did I lose anybody? Does it make sense? We're representing the changes now on this graph. The change in x is going to be a horizontal line, like the rainfall, like the blue bar on the rainfall, right? And then the change in y is going to be, because our scale is vertical, that's going to be some kind of vertical amount. Okay, so what I want you to do is choose a couple more from the x and y that I picked. Find a couple more changes in x. Find the corresponding change in y, and then sketch it on your graph. Everyone, so you all may have something different. So you decide. Start in column F there. Start at a certain x from column C. Get a change in x and the corresponding change in y, and sketch it. Go. So if you have a question right now, Roy and I can stop us, one of us, and we can help you. Yeah, you can work by yourself, or if you want to consult with the person next to you, either way, whatever you want. Anybody got questions? Yes, is there a question? Where's Candace? Candace Keelan. Is Candace here? Michaela. I said your name right. Where's Michaela? How'd it go? So can you tell me what change did you pick? 3 to 12. I'll do this in red. Three to 12. Your delta x is 9, and then what did y change from? I'm sorry? Uh-oh. Don't need the calculator for that. So it's all over there. All the info you need is in the table, right? Y goes from? 9 to 36. 27. Okay, first of all, how do you like that? Does she like what she did? X goes from 3 to 12, and Y will change from $9 to $36. Your change in weight would be 9, and the corresponding change would be 12. All right, and then how did anyone else pick that exact change? All right, so what's your name? Carter. Tell me about how I'm going to represent this on the graph. What should I do?
Okay, well, you're going to draw a horizontal line.
Okay, here you go. How about that?
Oh, sorry. on the line.
On the line. I'm just giving you a hard time. But yeah, you got to be specific. So tell me where to start.
You can start at 9.
Start at 9.
Sorry. Start at 9:36.
Start at 9:36.
9. I haven't gotten this first.
So focus there. X is changing from 3 to 12. Our starting X value is 3. So where should I start? Like here?
No, 3 on the line.
There you go. So this point, right? 0.39. All right, now what?
You're going to draw a line from that point over 9
Which direction?
to the right
And when do I stop?
at 12.
Maybe? Not bad. Okay? And that's delta
X.
X equals?
9.
Tell me from there.
And then from that point right there, you're going to draw straight up.
Straight up. I can do it.
Stop. And then delta Y equals 27.
How do you do? That's showing a change. So someone just explain the whole thing. So who can just explain that whole thing, what I've drawn in red? I've drawn in red. Yes, sir. Okay, so the change in the weight of 9 pounds starting at 3, starting at 3 what? 3 pounds. We start at 3 pounds. We increase, so it's like he had 3 pounds on the scale, and we were about to pay how much for that? 9. But they said, oh, no, wait. My whole extended family is coming. I need more chicken. So he's going to throw 9 more pounds on the scale. And what just happened to my price? My cost. Just went up $27 for doing that, right? Okay? How about this? Let's see. That's good. Okay, so what do we, if you notice now, so here, we'll just step back for a second. So calculus is all about how quantities change together. And that's why we're starting with representation of changes of quantities. All right, so on the first day of class, I said that this class was all about quantities, and that's true. But more specifically, this class is all about how 2 quantities change simultaneously. If you change one, that other one changes, right? So if you change the weight on the scale, you're changing your cost if you're a law-abiding citizen, right? Okay? If you increase the weight of chicken, you're increasing your what you're going to pay. Okay? So, calculus, the underlying idea of calculus is two quantities changing together and the different ways that they can change together. So now the way that these two quantities are changing together, the cost of chicken and the weight of the chicken, is very special. The way that they're changing together is very specific and very special. So, anyone have an idea? Articulate. Why is this particular way that these two quantities are changing together is very special? What is it? Yeah. Wait, what does that mean, though? So talk to me about the numbers. So yeah, you're right. So what is it there that's happening that's so special?
Well, the lines are shining at a constant rate.
Okay, we stick to the quantities. The quantities. Yes, ma'am. What's proportional? The slope, the distance from each other. Something about proportionality.
They're proportional. Both the pounds are proportional to the amount it costs.
Okay. True. Yes, ma'am. Focus on the quantities, the changes. What's special about the changes in the quantities? Every pound per dollar is the same. What's happening with the changes? Okay, so what is 1 to 3?
Every pound, for the 1 pound is $2.
So for every additional pound, can we say that? For every additional pound of 1,
There's one plus the 2.
is going to be 3. The change in y is always 3 times the change in the number of pounds, right? So let's get rid of this part. So this, someone mentioned proportionality. What quantities are proportional here? The changes, right? The changes are proportional. And so given any amount, any increase in the amount of weight of chicken, how could we find the cost, the additional cost, or the increase in the cost? What would we do? Multiply it by 3, right? Multiply it by 3. Okay? So what about here if I had, okay, I'm going to draw a point here. Was there a point there before I drew it? Oh, good, you passed, right. Yes, there was. All I did was highlight a point that was already there. That line is all points. And by drawing that dot, I'm just highlighting a point that was already there. What point did I highlight? And what does it mean? 10 pounds cost 30. Okay, I want to change now. I'm going to change from 10 to 8. Can I do that? Is it valid? So he put some chicken on there. Oh, I can't afford $10. You got to take some off. You got to take some off. So he takes off how much? What's delta x? -2, right? -2. How does y change when x changes from 10 to 8? 32, 24. You can do it in your head, right? And what change is that? Is this still valid for that right here? Change in x was -2. How much did my cost change? It changed -6. So when you take 2 pounds off the scale, your cost is going to go down $6, right? Okay. So when two quantities are proportional, so when you think of proportionality, what do you, think about back to proportionality problems. What did you do when things were proportional? Remember? What'd you do? So proportionality makes you think of what? Where's Diana? Where's Diana? Okay, so proportionality is all about equality of what? Do you ever do proportionality problems back in junior high, pre-algebra? And when you were doing those problems, what were you doing? Proportionality. You set up equations, right? Equations of what? Comparing what? Yeah.
Like comparing each two to make them proportionate.
Yeah. If you have proportionality, then what are you setting equal to each other? You don't set equations equal. Proportionality. Remember doing proportionality? Ratios, right? Ratios. Proportionality means setting up a ratio. Proportion, right? A ratio. What's proportional here? Or what ratio are we talking about? The change in y to change in x. Okay? And if you have proportionality, then what's true about that ratio? It's the proportionality. It's a constant, right? It always stays the same. And what is it in this case? Nope. Oh, this is harder than I thought. It's always equal to 3. The increase in cost divided by the increase in pounds is always going to be 3. Right? Because that was what? That was our cost per pound. So however much you increase the pounds by, the increase in cost will be 3 times that much, always preserving that ratio of 3.
It's K, right?
What's that?
It's K, right?
Yes, and oftentimes that's called K. All right? Or dollars. I should have said dollars here. Dollars. Okay, so one more aspect. So we're talking about, so he mentioned it. He said at a constant rate of change, right? This is what constant rate of change is about. The change in y, the ratio of the change in y to the change in x stays constant. Stays constant. This ratio of how much the cost changes to how much the weight changed in this scenario that's always 3 times as much. So that ratio will always be 3. So look, so the cost is always 3 times as much as the increase in pounds. So the ratio of the change in cost to the change in pounds is always 3. Okay, there's one more aspect of this that we can look at constant rate of change. So if I go from, say, 1 to 3, what's delta x? 2. How much more do I pay? 6. Okay, starting at 7. I'm going to buy 2 more, or I'm going to put a weight of 2 more pounds on the scale. How much does my cost go up? 6. Constant rate of change. What does it mean? So 11. I got 11 pounds. I want to increase by 2. What happened to my increase in cost? $6 more. This is the idea of constant rate of change. Can anyone summarize what I just showed in constant rate of change? That if you, what? Yeah?
The equation is linear. It's
What am I showing in this particular example? Somebody new? Yeah?
So every time you have an increase in delta x,
Okay.
take that and multiply that by 3, you get the increase in y.
Okay, yes, you kind of combine them both there. You can kind of combine both. If I have equal changes in the amount of weight, what will be the result?
Equal change in the amount.
Consistent changes in the increase in cost, or consistent changes in the cost, right? So if I always have the same increase in weight, no matter how much I already have on the scale, if I increase by the same amount, I'm always going to increase my cost by the same amount. That's constant rate of change. It's increasing constantly, so that you always pay $6 more for 2 more pounds. So let's summarize. Does it make sense? Okay, so let's summarize what we talked about. Two quantities vary together at a constant rate. Yeah. Okay, the first one on the list is the one we just talked about. Every time one quantity changes by some fixed amount, what happens to the other quantity? What happens to the other quantity? So every time your quantity changes, I had 2 there. I had an increase of weight of 2 every time. What's that? Increases for what? So, but every time I increased it by 2. What happens to my cost increase every time? By the same, 6. All right, so here's how I said it. Equal changes in one quantity result in consistent changes of the other. You're always going to get the same change as long as your initial change of the other quantity stays the same. Every time I put 10 more pounds on the scale, how much more am I going to pay? 30. 30, right? Every time, no matter how many pounds are already on the scale, if I increase it by 10, my cost always goes up 30. That's what this is saying. Constant rate of change. Half a pound. Every time I add a half a pound onto the scale, what's going to happen to my cost? Go up $1.50, right? Go up $1.50. What else did we say? We said that the change in one quantity is a constant multiple of the corresponding change in the other. The change in one quantity is a constant multiple of the change in the other. Meaning, if you know how much the weight went up, how do you find how much the cost went up? Yeah. You multiply by 3 every time. No matter how much the weight goes up, you're always going to multiply that by 3, and you get how much the cost goes up. That's what that's saying. So our constant multiple for our example was 3. The number of dollars, additional number of dollars, always 3 times the additional amount of weight. And then what was the last one we said? Anybody remember? Yeah.
If it goes by 10, if I add 10 pounds and I add 10 pounds again, it's always going to be the same one.
That's the first one. Yeah, that's the first one. What was the, I don't remember the last one we said? Yeah. Oh. Yep. The that ratio of the changes stays the same. The corresponding change in the two quantities maintains a constant ratio. So that ratio of change in cost to the corresponding change in weight, in our case, always 3. Always stayed 3. Okay, if you came in late or I didn't call, you were here but I didn't call your name, make sure you get up and we'll get the attendance sorted out. Don't forget the pretest, today or tomorrow. The ratio is the dividing. So when you divide the change in y by the change in x, delta y divided by delta x, it's always 3, right? Because the change in y, that's always 3 times as great as that. So that ratio is 3.
Thank you.
Yeah. Okay. Let me just wait a second.
Yeah.
Thank you.
Yeah. It took me forever to lock my bike.
Sir. Okay, cool. I'm just letting make sure people. Okay, it's going away. Are we good? Everyone got it?